All right, welcome back, everybody. When I left you last time, we were just setting up this situation right here. We'll solve for x in a moment. I just want to recap real quick what we're doing with this problem. And so in all these problems, but specifically we're talking about number 2 here, we're finding area and perimeter of a trapezoid. And so what we discussed was in order to find area, right, area is going to be base 1 plus base 2 times by our height and divided by 2. Now we have our two base numbers, 12 and 15, but we do not have our height. Remember, our height makes a 90-degree angle with our base, and so this right side going straight up and down, we'll call that our height. As we talked about in the last video, we can write that h over here on the left side as well. It's the same kind of idea, right? And so that's where we're going to find h. Now we have to do things to get it, but that's kind of where h exists. Now, remember, h is also one of our sides. It's the straight up and down side. So we need it for our area and we need it for our perimeter. And then lastly, we need this slanted side over here in which I've labeled x to finish off our perimeter, right? Because that slanted side is going to be one of the sides of our trapezoid. And so what we've done so far is just start this process of using sine, cosine, or tangent. Remember the SOHCAHTOA stuff, in order to figure out what h and x are. Because as you can see, I've written them both over here on this imaginary triangle off the end of our trapezoid. I drew that triangle down here, and we recognized h as the opposite side, x as the hypotenuse, and then 3 as our adjacent side. And we're working with this 60-degree angle. Now, we already solved for h. We did that by setting, h comes from the opposite, the 3 comes from the adjacent, so tangent of 60 will equal h over 3, and we solve for h. Now we're working on finding x. We set that up because cosine of 60 is adjacent, which is our 3, divided by hypotenuse, which is our x. And so cosine of 60 will equal 3 over x. And so now we just need to solve this. Remember, we're going to times by the bottom of the fraction to both sides, so we'll times both sides by x, and those will cancel. And so it'll equal 3 on the right side, and x times cosine of 60 on the left. So then we'll just divide by cosine of 60 to get x by itself. And the cosines of 60 on the left will cancel, and x will simply equal 3 divided by cosine of 60. And then we just need to type that into our calculator, and that'll tell us what x is. So let's do that real quick. Grab the calculator. Remember to be in degree mode. We talked about that in the last video. So mode, search for degree and radian, highlight degree, and hit enter on it. And so again, we just want to type in 3 divided by cosine of 60, close the parentheses and hit enter, and we get 6. We get 6 for x. And so come back here and we'll write that down. All right, now I haven't done any work with area or perimeter yet. However, I have found everything we need. I found our x and I found our h. And so now I'm going to take this and clean up this trapezoid here, and I'm going to just write that stuff down. Remember, our h is on this right side. We will call that 5.2. And remember, our x was this slanted side. We know that is now 6. So let's start with perimeter. It's generally pretty straightforward. So we're just going to add all 4 sides. So that's 15 plus 5.2 plus 12 plus 6. And when we add all 4 of those sides together, we should get 38.2. And meters are our units, so our perimeter is 38.2. And now we'll just plug the things into our area formula over here. And so our area will equal our bases added together. Our bases are the parallel sides, remember? So 12 plus 15. We'll times that by our h, which we solved for, which was 5.2. And then we'll divide by 2. I'm going to take this algebra to the right. So 12 plus 15 is 27. Got to times that by 5.2 and then divide by 2. And then when we do all of that, we will get 70.1 meters squared for our area, 70.1 meters squared. All right, so that concludes working through finding area and perimeter of trapezoids. Perimeter, as always, all the sides added up. Area deals with this formula right here. All right. Now, let's move on to kites. Just a couple problems for kites. So the kite area formula is something you already are familiar with. However, we haven't phrased it in the sense of a kite yet. And so what I mean by that is this. Here's just the area formula right off the bat. Diagonal 1 times diagonal 2 divided by 2. Now, a couple things to refresh our memory about kites. First of all, consecutive sides are congruent in a kite. And so I know this side and the one next to it, where they meet at this point right here, those two will be the same. And then the two sides on the right, they'll be different than the two on the left, but they will be the same. Now, that's just kind of what a kite has, some properties of it. Remember, the area deals with the diagonals though. So now I'll draw them in red. Now, it's relatively simple, right? One of these is a diagonal. We'll call it diagonal 1. The other one's diagonal 2. Doesn't matter which one's which. Any one can be diagonal 1. The other one can be diagonal 2. Doesn't matter. Remember, these are full diagonals. And one thing we need to know about kites are these meet at right angles here. And one of the diagonals, in this case, the vertical one, gets cut in half. The other one does not, and generally will not look like it does, so you should be able to visualize it. But one gets cut in half, one does not. And so that's something important that we'll use as we, try to piece together full diagonals so we can plug them into our area formula for a kite. So let's see how it works here. Find the area of this kite, round to the nearest tenth. So a couple things. Obviously, the diagonals are already drawn in here, and we know a little bit about each of them. This one right here. We actually know this full diagonal. This is 12, the 12 part and the 3 part. So in total, this diagonal is 15, which means we know nothing about the other diagonal, right? I shouldn't even do it in red. Let me make it green. So we have this other green diagonal, and we don't know anything about it. So I'm going to call one side of it X. The only thing I do know is that this is the diagonal that gets cut in half. And so this half where X is going to be equal to this other half. And so if we can solve for X, then we'll know what X is and we'll know what the other side is. And we'll have all we need for diagonals to find the area of the kite. Now, what I need you to recognize is this. Where these diagonals meet, create 4 triangles in the kite. Right? And so I'm going to draw this orange triangle out here farther so we can just see it better. This slanted side is the 5, this bottom side is the 3, and this left side is the X that we want to find. And just like in our diagram up top, these diagonals meet at a 90-degree angle. And so we can do a squared plus b squared equals c squared, the Pythagorean theorem, to solve for our missing side. Now, remember, c is across from the 90, so that'll be our 5 here. And so this situation is going to be x squared plus 3 squared equals 5 squared. And so we'll solve this. X squared plus 9 equals 25. Subtract 9 from both sides. X squared equals 16. And then we'll take the square root of both sides. And x will equal 4. And so let's put that up here. X is right here. I now know it equals 4. What a terrible equals sign. I'll just put a 4 here, right? Now, I only worked with, this triangle here, right? And so 4 is only part of that diagonal. The other side is 4, which means that whole diagonal is 8, right? We need full diagonals. But now we have the full diagonal. The orange and green one is 8. The red one, a little piece of orange there, is 15. And so now our area is simply 8 times 15 divided by 2. And when we type that into our calculator, we are going to get 60 feet squared. And that is our area. All right. Now, the next one has a whole lot going on. So buckle up. It's the last problem for part 3, and it might take quite a bit. I'll try to be clear about everything, and we'll review some past skills that are going to be important to be able to figure out what we need to be able to find the area and the perimeter of this kite. So perimeter means, right, we need all 4 sides on the outside. And right now we know none. Now, for area, we need to simply just find, not base, diagonal 1 and diagonal 2. And then, right, we'll multiply those together and divide by 2. Now, one thing to note, this 4, that's part of, I'll make this, I guess, the purple diagonal. And that's the one that gets cut in half. And so if the right side's 4, the left side's 4. And so our entire purple diagonal is 8. 4 plus 4 is 8. So we do have one of our diagonals. And we have a little piece of another, right? If I make this one the orange diagonal, you will see that the bottom part of the orange is 8. But the top part is not 8, and the top part should not look the same as the bottom. And so it didn't get cut in half, and so we can't just write 8 again. And so we actually have to solve for it here. And so let's do it. And what I want to do is highlight this green triangle. I'm going to draw that again over here. And here's why. I'm going to call this X, I guess, for now. And that's this side, right? That's the rest of this orange diagonal. Once we get that, we'll be able to find our area. Now I know the bottom here is 4. And then I'm going to call the side, the slanted side, Y. Because I'm going to need to figure out that side if I want the perimeter, right? I need X for my area, but I do need Y for my perimeter. So let's find them both. And we're going to be able to find them both because we know this is a right triangle, and we know this little angle here is 40 degrees. And when we have angle measures and one side length, we can use sine, cosine, tangent to figure out the other sides, right? And so this brings us into SOHCAHTOA again. And so let's, oops, not SOHCAHTOA, SOHCAHTOA. And so let's utilize this and let's solve for X and Y. Let's start with X. So from our 40-degree angle, X is the opposite side. Y is our hypotenuse to cross from the 90, which leaves 4 to be our adjacent side. And so if we want to solve for X, we need to work with our opposite and our adjacent. And so opposite and adjacent, that would be the OA part in TOA. And so we can solve for X by doing tangent of 40 equals opposite, which is X, divided by adjacent, which is 4. And so we can solve for X by multiplying both sides by 4. The 4's will cancel, leaving X on the right. And what we need to type into our calculator is 4 times the tangent of 40. And when we type in 4 times the tangent of 40, we will see that X equals 3.4 if we round up. 3.4. Now, that's important, so I'll underline it. We'll come back to that and use it again. Now, let's solve for Y now. All right, let's solve for Y. And so same setup, except for we don't care about X this time. We want to find Y, which is on the hypotenuse, and the other number we know is still our adjacent, which is 4. And so we need to work with adjacent and hypotenuse. Adjacent and hypotenuse. That's the part of C, right? So we're going to work with the cosine. So the cosine of 40 is going to equal adjacent divided by hypotenuse. So 4 divided by Y. And so we'll take the same approach as always. We'll multiply by what's in the bottom of that fraction. So my Y's will cancel out on the right, and it'll leave me with 4. And I'll have Y times the cosine of 40 on the left. And then I'll just divide both sides by the cosine of 40. And the cosine of 40 will cancel on the left, leaving me with Y equals 4 divided by the cosine of 40. And I just type that into my calculator, and that'll tell me what Y is. And so when I do 4 divided by cosine of 40, it tells me 5.2. 5.2. And so I'm going to write that down. Y is 5.2. And again, that's something we're going to need to know, but we just can't utilize it yet. And we will finish this problem off in the next video. Thank you very much for your hard work. See you in a sec.